In this video, we're going to discuss an economic application of rational functions. And this application is called the average cost function. What is this? Well, we recall from working with lines that we could do a cost function that looks something like this, where m is our variable cost, or the cost per unit, and b is our fixed costs. So what do we mean by each of these? Fixed costs are going to be anything that the company has to pay whether they're producing stuff or not. For instance, the rent on the building, their phone bill, the employees they've hired, although you can argue that might go under a variable cost, but we'll think of that as a fixed cost. While the variable cost is the amount it costs to produce each item individually. For instance, we might have a company with $600,000 in fixed monthly costs, and let's say this company produces headsets of some kind that cost $50 each to produce. As a variable cost. Then our general cost function is going to equal 50 times x plus 600,000, where x is the number of headsets we produce. But I claim something looks weird here. I said it costs $50 per headset. But if they only produce one headset in that month, then they paid $50 for that headset, but they also paid $600,000 to just keep their business up and running, which means they really paid $600,050 to produce that one headset. And that doesn't seem to work out very nicely. Let's say they produced 100 headsets at $50 each. That would be $5,000 to produce that. But it's not really $50 each headset because they had this $600,000 cost already, which means they really spent $605,000 to produce 100 headsets. So it really cost them more than just $50 per headset. So we get our average cost function, which we abbreviate with a C with the line over it. And we start with that 50x plus 600,000. But we're going to divide that by the number of headsets produced. And from the two things I've stated, that seems to make sense. If we only produce one headset, then that headset cost $600,050. Let's write that down. That's a lot to spend on one headset. 100 headsets, while the total cost we said was $605,000. Since I produced 100 of them, if I take this and divide it by 100, that comes out to be only $6,050 per headset. And while that's still a lot compared to that $50 per headset cost, that's a lot more reasonable. And that's what we just did. We took the cost of producing those headsets divided by the number of headsets we produced to get what we call the average cost. And now let's look at this function. What happens if I evaluate C bar of 1,000? Well, we have 50 times 1,000 plus 600,000 over 1,000. 50 times 1,000 is 50,000, plus 600,000 is 650,000, over 1,000 is just $650 per headset. So what this means is if I produce 1,000 headsets, then it will cost us $650 per headset to produce it. What about if we do C bar of 10,000? Oh yes, this symbol here is called a bar, so this function we read as C bar. Well, then we've got 50 times 10,000 plus 600,000 over 10,000. 50 times 10,000 is 500,000. $600,000 plus 500,000 is 1,100,000. Divide that by 10,000. We can do that quickly by just crossing off common zeros. We get $110. So, if we produce $110, then the average cost per headset for 10,000 headsets is $110, which of course makes it cheaper per headset for us to produce, which means we can sell them for less. So that's a very useful application to have. The question I'm going to leave you with, and not actually answer, you can do this in the discussion, is as we produce more headsets per month, what is the average cost per headset moving towards? Or probably a better word would be approaching. I look forward to your answers.